ask your doubt and then you can. Okay. Hello everybody, a very good afternoon. Today we are starting with a new chapter, that is metallurgy. In the previous videos and the sessions, we have already completed with the chapter electrolysis and the previous chapters. So today we are starting with this metallurgy chapter. So let's start. So first of all, let's understand the meaning of the word metallurgy. Okay. So what is actually metallurgy? Metallurgy is the extraction. Please write it down. Please take down notes. That's why I'm not bringing a printed PDFs for you all, right? I'm making the notes with you all so that you also take down the notes, right? Extraction of metals from earth crust, or you can just make an apostrophe S here. Earth's crust is called metallurgy. Okay, so this is the term, this is the meaning of the term metallurgy. Okay, very important definition, please make note of this. So what are the keywords in this? Extraction of metals. Like, see, the metals are not available like they are, like we see them, right? They are not as we see them. Like if we have an iron bar, is it available in nature like this? No, it's not. It's actually present how? It's present in the form of rocks. Yes or no? There might be a rock in which somewhere this pink colored, let's make it pink colored, iron must be embedded. Yes or no? Now we have to take this off, and we all know that in this iron also we must be having many impurities, right? Like sand, like clay, yes, dhool, mitti, etc. Everything is there inside it, right? Many impurities. So to extract, so to get these metals out, to get this out, we perform a process that is known as metallurgy. And metallurgy is such a vast topic that one branch of engineering is based on this. Okay, you must be knowing the word metallurgical engineering, isn't it? So let's start with the second point. Now, the second thing which you all need to keep in mind is the meaning of the word minerals. Okay, now we'll talk about some terms. First term is minerals. So what is minerals? Please write it down. We all know that minerals are what? Which are having metals, right? So let's write it. So they are the compound which contain what? I told you all just now, they contain metals. Okay, now with some impurities. They are not pure metals, they have some impurities. Okay, so it's called the minerals. Okay, now simply what? Minerals are metals plus impurities, isn't it? Like this we can write it down. So minerals, you all know now what is minerals. Okay, next definition which we all need to know is the meaning of ore. Okay, I am strictly following the syllabus, nothing else. Okay, so what is ore? Ore is a mineral, a type of mineral, okay, from which metals can be extracted. Metals can be extracted. Okay, now there are two ways that it can be extracted. We look for two criteria. The first criteria is, first, profitably. Very important, it's a keyword. You don't write the definition, write profitably, and easily you will get 2 marks. Okay, and the second criteria is easily. Okay, so mineral is what? From which metals can be extracted, how they can be extracted profitably and easily. Understood? So let's now move on to the next part of the syllabus. In the next part of the syllabus, we have to cover some common ores. Okay, now there were many ores which we had to do before the reduction of the syllabus, but as we all know that the syllabus has been reduced to a lot more extent, right? So the syllabus has got reduced, so we just have to do what? we just have to do the common ores of aluminium. Okay, we just have to do common ores of aluminium. So let's write it down. There are 3 common ores of aluminium. You have to learn the common name and the formula also. Okay, so the first one is bauxite. You all must be knowing this. There might not be any child who is not aware of this term bauxite, and we all know that it's a ore of aluminium. It is an ore, it is a type of mineral which consists aluminium inside it. Yes, and it is the main ore, right? The maximum amount of aluminium that we get is from bauxite only. Okay, now write down its formula also. What is its formula? Al2O3.2H2O. That is, it has 2 waters of crystallization, or we can call it, or what else we can call it? It's hydrated, isn't it? It's having water of crystallization, so we can call it hydrated aluminium oxide. Still, let's move on to the second one. The second ore is cryolite. Okay, cryolite. Now, what is the chemical formula of cryolite? Let's look at it. Chemical formula F6. Okay, and what do we call it? It's called, we have read this in analytical chemistry, right? Sodium aluminate. And here is one more thing, that is this fluorine, right? F6. So we'll call it sodium aluminate fluoride. Okay, that's all. Next, we move on to the third and the last ore, that is corundum. Okay, or you can just pronounce it more frankly like corundum. Okay, next. So what three? That is simply aluminium oxide. Okay, that's simple. So that was all. Next, we'll talk about the extraction of aluminium. So this whole chapter, we had to do so many metals, but due to the reduction in the syllabus, we just have to do aluminium, common ores of aluminium, the extraction of aluminium from its main ore. What is its main ore? I've told you all. What is its main ore? It's bauxite. Okay, and these are not main. These are just, you know, ores, but these are not very usually used. Okay, so next we move on to the extraction. So now we are moving on to the next topic, that is extraction of aluminium. So the first point to be noted is it is mainly bauxite which is used. Okay, mainly bauxite is used. Done. Then what is the process? What is the ore actually we are using? Okay, so let's look at the ore. What is the ore we are using? We are using bauxite now. Yes or no? We are using bauxite. So write down bauxite. Okay. So okay, so write it down. The main ore is bauxite is used. What I've already told you the formula. What is the formula of bauxite? Al2O3. So write down the first. So in the first step, we'll be removing what? We'll be removing this impurity. Okay. So in the first step, we'll be removing this impurity. So you can write that this impurity has to be removed. So this process of removing is called purification. Okay, this is called purification of ore. It is also called dressing of ore, means dressing, you know, dressing table and all. It's known as dressing of ore, and it's also known as the concentration of ore. Okay, so for this we use a process that is known as the Bayer's process, a very important process. You must have heard about it in your syllabus. It's the Bayer's process. So please pay attention in this process. It's a very important one. Okay, so what do we do in this process? We convert. Okay, give me a minute. What do we do in this process is so what do we do is we convert impure bauxite to pure alumina. What is pure alumina? Al2O3. Okay, and what is impure bauxite? Al2O3.2H2O. So we have to remove the 2H2O. Yes, so what do we use? So there is a series of steps. Let's start. Step number 1, what do we do? Al2O3.2H2O, that is impure bauxite, plus sodium hydroxide we use. Okay, very important, please note this, we use sodium hydroxide. Okay, what do we use? We use sodium hydroxide. Next, what do we get? We get a very familiar compound. We have already studied this in analytical chemistry, NaAlO2, right? Yes, now tell me the name. The ones who have paid attention
Sodium
must be knowing.
aluminate.
Yeah, it's sodium aluminate. So it's what? Sodium aluminate. Okay, now next thing, this is what? This is soluble salt. Okay, now a question might arise in the board that why we are using NaOH, right? So write it, why NaOH. Okay, so the answer to this question is that this answer is it is unreactive. Okay, it is unreactive with impurities. We all know that it is having some impurities. Like, what are the impurities? Silica, that is SiO2, that is sand, yes or no? We have iron also, so FeO3, yes or no? So it does not react with it. Additionally, one more point is there, that it is insoluble. Okay, so so what I told you all, what are the impurities? FeO2 also. Okay, Fe2O3. And the next point is that these impurities, SiO2 and FeO2, these are okay, these are insoluble in NaOH. So they do not dissolve. Okay, sodium aluminate is soluble in it, but sodium, okay, write down the compound only. Okay, I know it might be boring, but please try to understand. NaAlO2 is soluble. So see what is happening in NaOH. Why we are using NaOH? Because it does not dissolve SiO2 and Fe2O3. That are the impurities like sand and mud, isn't it? But it dissolves the thing we need the most. Yes, what do we need? We need aluminium. So it dissolves the aluminium particle. What is the aluminium in this? NaAlO2. Yes or no? It is having aluminium, so it has dissolved it. It is understood. So we are moving on to the step number 2. Step number 1 is clear now. Say yes.
Yes.
Okay, so we are moving to step 2. Step 2. So in the step 2, what happens? The conversion of sodium aluminate is happening to sodium hydroxide. So let's write it down. What happens? Conversion of sodium aluminate to aluminium hydroxide. Okay, what happens? We dilute it. Okay, how can we dilute it? Tell me, what is the process of diluting? Add water to a substance, the concentration will decrease, yes or no? So we add water to it to make it dilute. So we are doing the dilution. This is called dilution. Okay, dilution. Okay, and what happens? NaOH plus AlOH whole thrice is there as a precipitate. So we have got the thing we wanted, yes or no? We wanted to convert sodium aluminate to sodium hydroxide. We have converted it, yes or no? Now can you see everybody? Yes, we are successful in the process. So what is the temperature which is required? This is a very important question, can be framed for this. 50 to 60 degrees Celsius. Okay, is the temperature which is required for this. And the temperature which is required in the above process, which we just wrote, this one is how much temperature is required? 150 to 200 degrees Celsius. Okay, so this is the temperature, and 2 to 8 hours is the time which is required. Okay, next, now what is done? Al2O3 which we have get, this is filtered out. Okay, it is insoluble. It is PPT, yes or no? It is insoluble, that's why it's precipitated. So it is filtered out, and then what it is it done? It is dried. Okay, so how to dry anything? Heat it, isn't it? Heat it. So this is the step number 3. So step 3 is heat it, convert Al to O3. Okay, 1 minute. So the step number 3 is to convert AlOH whole thrice, that is aluminium hydroxide, which we have got, to pure alumina. What is pure alumina? I've told you all the compound name, Al2O3, isn't it? So how to convert it? We want to dry it out, isn't it? So this is only what we call as drying. Understood? Yes. So let's do that. So for drying, what do? We heat a compound, isn't it? So let's heat this up. So we have this AlOH whole thrice. Okay, let's zoom in. And what we do? We heat it. Okay. So let's write it AlOH whole thrice. We do heat it. Okay. So what is the temperature required? 1100 degrees Celsius is required, and then we get Al2O3 plus H2. Okay. Now, so that was all for the Bayer's process. Let's take an overlook of this. Okay, overview of this. So let's draw flow chart so that it's crystal clear in your mind. Okay, so the flow chart is, first of all, we do what? Al2O3 is there, 0.2H2O. Yes, we react it with sodium, and we get what? We get sodium aluminate. Yes or no, guys? Nobody is replying. Understanding or not? This was the first process. Then what happened? Then what did we do? We had temperature of 150 degree to 200 degrees Celsius. Yes. So 150 degree to 200 degrees Celsius, and for 8 to 10 hours. Okay. No, from 2 to 8 hours. That is done. Next, we move on to the next step. What was the next step? I told you all. The next step was this NaAlO2, which we got, to convert to dilute it, isn't it? We diluted it by adding water, and we got AlOH whole thrice, isn't it? And this was at a temperature of what? This was at the temperature of 50 to 60 degrees Celsius, and the time limit was nothing. Okay, so this, yeah. Next, we move on to the next. At last, what did we do? We have taken this ALOH rice and we heated it. Yes or no? We heated it to get what? Al2. This is the process of Bayer. This is 100. Yes. First process is what? First process is just the first step, and then this process is called dilution, and this process is called heating or drying. Okay, so this was the Bayer's process. Understood? In one page we have completed the Bayer's process. Now see, this was the step one. Can you see here? This was the step one, isn't it? Can everybody see this? Yes, so it was step number one. We actually have how many? We have only converted it to Al to O3. Isn't it? Now we need to get it in the form of pure aluminium, that is Al, that's all aluminium, and that to 99% pure. So how to convert it, we'll be doing that in the next video, and we have some drawbacks also, so we'll be doing that in the next video. Let's talk about the drawbacks in the next video, and we'll be doing one more process, that is Hall and Herold's process and the Hoops process. Please do watch that video, it's very important. Till then, a very happy learning.